Morning, everyone. This is Jeff from Rust Bucket Valley Garage. We're back in Los Angeles today, and I thought I'd take and start up a series about the different generations of engines that are in the cars today. If you don't have one, which this vehicle does not because it's currently being overhauled, this was the Kia that we pulled the engine out of because the bearings were shot in it. Um, you have a problem, or if the engine's not in good shape. But I'd like to take and give you a little engine 101 on the different six generations of engine that are available right now, and also what the parts do. Okay, so and the various changes. So let's go ahead and start that up. So today I'm going to take and give you a little bit of information on the six generations of engines that are currently in use in the United States and also a lot of the Asian engines. The first generation would be considered the engines when they first came out, 20s, 30s, like that. They were the flathead engines. When you look on the cylinder head, it was a flat head. It just had spark plugs in it. All the guts for the engine were actually in the block. Um, the valves, the camshaft, the crankshaft, the pistons, everything was in the block. It was a manual start engine. You had to take and crank it by hand. There was a crank that came out the front of the car. You had to engage the crank in the crankshaft. You had to take and crank it by hand. It was a manual ignition where they had a magneto which would take and create electricity when the engine was spun over. So they did not have a separate battery to take and crank the starter motor, because on these ones you were the starter motor. um, so if you move to the 1A generation, okay, so we just went through the 1 with the flatheads, and the 1A, they came out with electric starts, starter motors. They had a storage battery that you could take and turn a switch and push a button on the floor, and you could take and start your engine up that way. They had a generator that would recharge the battery. They had gears for timing. I'm talking about engine timing, which would time the camshaft to the crankshaft. The next generation, which would be actually generation 2, they came out with alternators that where the generators created DC voltage, the alternators create AC voltage, and it changes it to DC voltage via diodes that are in the alternator. So a lot of times when the alternator goes bad, it's the diodes in there that go bad. They had the engine block with the valves in the block still. They had, for timing mechanism, they had 2 gears, 1 gear on the crank, 1 gear on the camshaft, and they used a chain to take and keep them synchronized for timing. The next generation would be generation 3, which were the Mazda rotary engines. The engine had triangular rotors instead of pistons. That was kind of a hoot. They were real popular when they came out. Didn't really catch on so much. Fourth generation was the flat engines, where they had horizontal cylinders. They had, like Volkswagen and Porsche, 4-cylinder, 6-cylinder. They had horizontal cylinders. Fifth generation would be where the camshaft and the crankshaft is in the middle of the engine, and it was driven by 2 gears and chains. and the valves were in the cylinder heads or head, and they were driven by lifters and push rods. And I will show you all of that as we take and go into the engine portion of this talk. But the sixth generation would be the overhead cam engines, which is typical to a lot of the Asian engines, where you have the cam and the crank that are synchronized by timing chains and timing gears. The timing chains are very long on these. The valves are in cylinder head. There are no lifters. The opening and closing of the valves is directly controlled by the overhead cams. So they will have, if it's a dual cam, they will have one cam for the intake valves. They have one cam for the exhaust valves, and via the timing chains and gears, they will be synchronized. There are no push rods in this engine. So let's start out here with this engine right here. I'm just using it as an example. This is a 302 cubic inch engine. If you're into metric, it is a 4.5 liter. It's about 300 horsepower. Engine capacity of oil is about 5 quarts. As you go with the engine sizes, they are different quantities of oil. This engine right here is from the 70s, and we happened to find a block that we could take and build that was good enough that we could take and board out, put some pistons in, and make a stock engine out of it. It is regular induction, where you have right here you have the carburetor. The carburetor is a 2-barrel carburetor, where they have a 4-barrel carburetor, which it indicates a number of venturi or holes in which go down into the engine to do the air-fuel mixture ratio. If we go ahead and we'll pull the top off of this, you'll see that there's a single port, and if you look down in here, there are 2 ports down in here that one goes to one bank of cylinders, 1, 2, 3, 4, and the other side goes to the other side, 4, 5, 8, 7, 6, 5. So, and it has jets in there that they can give a little squirt of fuel. All of your fuel mixing and everything is done with this. This is a carburetor. It's made by Holly. Very nice piece of equipment. This engine right here does not have a bunch of sensors on it like the later ones do. About the only ones it has on it is for oil pressure, and that is down right here, right next to the oil filter. Okay, and it has another one up on top of the engine here for engine water temp. It has a single coil that has a single wire that goes to the distributor cap. There is one wire on here for each cylinder. If you get it mixed up, the engine will misfire, won't run right. Inside this cap is a rotor that will take the spark that is delivered via this high tension wire to the center of a rotor, and as the engine turns, there is a shaft with a gear on it that comes off the camshaft, and it turns around and distributes the spark to each cylinder as needed. This particular engine uses points and a condenser. Condenser is like a capacitor, stores energy. This one here also has an alternator. It is a single wire exciting alternator, which means that the voltage regulator is in the back portion of the alternator. There's a single fan belt that takes and drives that. The water pump is right here. There has been many changes in the sizes of water pumps. Many changes in water pumps over the years. This right here is a type of water pump that would be on an engine like that. This one right here would be on an Asian engine. So if you compare them side to side, big difference, okay? For the larger engines, you need an awful lot of cooling. For the smaller Asian engines, they mostly depend on the oil supply to take and keep everything cool. On the 302 engine, you will see this device right here. This is a fuel pump. This is run off of a like a device. It's kind of like a cup, but it's off center, so it's like a cam. If you were to take and remove this this little piece of hardware here, there would be a lever that would come out of that, and it would run on that cam, which is connected to the camshaft, and it would provide an up and down motion to allow this to pump. On this side over here, we have the starter. It's a Ford starter. It takes and goes into the flex plate. A flex plate is a stamped piece of metal which has gears on the outside of it, and there is a device on here called a Bendix Gear. It's right here is what the Bendix Gear looks like when electricity through the storage battery is run through the key. It goes to a solenoid that is on here, and it takes and energizes the solenoid, which is a lever that is in here, which makes this this gear protrude into the gear and spins the engine over. That gear is connected to the back of the crankshaft. So if you have some kind of defect where when you turn your key on and it grinds, makes some horrible sound, either some of the teeth on this are damaged or some of the teeth on the ring gear are damaged. And let me show you what a ring gear looks like. Okay, we're back on the key that we took and pulled the engine out of. This is a ring gear right here. This right here goes on the torque converter, which goes into the transmission. The torque converter is kind of a pump that generates pressure so the transmission can run properly. But if these teeth on here get chewed up, these are a little bit chewed up, but they're not really that bad. So this is a serviceable part. Your starter takes and mounts right here. So, and then there's 1, 2, 3, 4 screws that go into this torque converter, and those will go into a transition plate that will be attached to the crankshaft that will take and go into your engine. So when you take and activate the starter, the teeth go into the ring gear, which this whole thing is a ring gear. It will take and spin the engine over, and if everything else is operating properly, then it will go ahead and start your engine. So on this particular engine here, there are sensors for everything. I would imagine there are probably no less than about 30 sensors on here, so that the engine control module can monitor everything. And one of the sensors, the knock sensor, was one of the reasons that we overhauled this engine, because the knock sensor was like an impact sensor, and it noticed, oh, something's knocking around the engine, so I better put it in limp mode. So basically we got this engine torn apart, and we're waiting for another engine. But let's go back in the shop, see what else we can cover. Now the other main difference on this engine is that the air-fuel mixture is fed from the middle down through the valves and then out the exhaust, but it's on both sides. Okay. Obviously, if it were a 4-cylinder engine, which happens to be an 8, it would be just in the middle. Next time when we get together, we'll start getting into the nitty-gritty as to what parts are what and what everything does. And hope you'll take and hang around for part 2. And in the meantime, I hope you have a wonderful day. Please subscribe and hit the notification button when we put up new content. You'll be the first to know. I think you'll really enjoy this series, and please comment. See you next time.